Good afternoon, students. I hope you can hear me. I'm audible. Okay, so in the last class, we started with the object diagram. Few points were remaining, but we could not complete due to the technical issue. So today we would complete those points and we'll start with data dictionary. So we were discussing, we have already seen about 1 second. So we were there were few points which were left that were object diagram can be described as an instance of class diagram. Thus, these diagrams are more close to a real life scenario where it can be implemented for a system. Okay. Now these object diagrams can be called as a set of objects and their relationship like the class diagram. So when I was drawing class diagram and I was explaining it, so I told that it is exactly like a class diagram where the things would be uh, in more detail compared to the class diagram. The look would be the same because from the class, the object would be connected, but here their attributes and operations and functions would be described. They would be uh, depicted in detail so that it can be uh, clarified or the information can be conveyed easily. Now they also present the static view of the system. Okay, the system which we are working on, the model which we are planning to design. So that it would also give us the layout of that particular system. The usage of object diagram is similar to the class diagram. Okay, because both are related to each other, but they are used to do prototype of a system from a practical perspectives. Now, where we are talking about implementing any software, where we are talking about the working of any software, if we are talking about how the data transaction or the flows are being taken place, how the data is being taken, how the inputs are being taken, how it is being processed, it is being modified. So those all things would be done in the prototype model. That is a dummy model, and that would be shown with the help of this object diagram. Now, let's see what are the elements of this object model. So object models elements are, there are a few major elements and few minor elements which we have to keep in mind while we are working on object model and we are drawing any object diagram. Okay, so in this, the major elements are abstraction, encapsulation, modularity, and hierarchy. But whereas we'll be talking about the minor elements, so there are three minor elements, that is typing, concurrency, and persistence. Okay, now let's see how these all work and what are their roles in object model in making object model successful. Now let's discuss about the major elements. As we know that in major elements we have abstraction, encapsulation, modularity, and hierarchy. So abstraction, we know that it denotes the characteristics of an object, okay, that are different from other kinds of objects, and it provides us the concept, visual boundaries, and the relative perspective of the viewer, what he's thinking of and how it should be made. Now, the behavior of an object can be categorized by considering the services that it provides to other objects as well as the operations that it may perform upon other objects. Okay, thus these things are being done. Now, if we'll talk about encapsulation, so it is the process of distributing the elements of an abstraction that constitutes its structure and behavior. Now, in our encapsulation, we usually bind things. We know that. So, it is the process of distributing the elements of an abstraction that constitutes its structure and behavior. Encapsulation can be called as a separate contractual interface. Okay, it would give us a layout of the abstraction and how it implementation would be performed, means on based on that information how the things would be processed and how the operations would be performed. Now, abstraction and encapsulation are complementary concepts. They are complement to each other. Okay, so thus we can understand its working. Now, modularity, how densely it is connected in the property of a system that has been decomposed into a set of cohesive or loosely coupled modules. Now, the modularity would tell us in the object model how objects are connected. Means a single object is connected to what are the processes, operations, or objects or classes. Okay, so it will show the modularity value would give us how densely it is connected. What is the value? How means which type of relationship has been performed, one to many, many to one. So that all things would be shown here in modularity. Now, if we'll talk about hierarchy, so it is the ranking of ordering of abstraction. Now, hierarchy would give us the ranking of order of abstraction, where the knowledge, the information about that particular object has been stored. Now, the two most important hierarchies in a complex system are its class structure. Okay, now class structure, that is a or generalization or specialization, and object structure part of or whole part. Inheritance is the most important, is a hierarchy. Okay, inheritance would be a very important thing where it would depict is a hierarchy, and basically inheritance defines a relationship upon classes wherein one class shares the structure of behavior defined in one or more classes. Now let's talk about the minor elements of the data model. Now, minor elements we have typing, concurrency, and persistence. Now, typing, it is the concept of typing derived primarily from theories of abstract data types. Okay, a type is a precise characterization of structured behavioral which a collection of entities also share. Now, typing is the informants of the class of an object, such that objects of different types may not interchange. Okay, so that when we are having objects of different types, they should not interchange with each other, and they should only interchange very in a restricted way. Means they should have communication in a restricted way. The data should be transferred. Now, if we talk about concurrency, so it is the property that distinguishes an active object from one that is not active. Now, persistence is the property of an object through which its existence transcends time, that is, the object continues to exist after its creator ceases to exist, and space, that is, the object's location moves from the address space in which it was created. So, persistence, we can say that it was the property of an object through which we can estimate about the time of its existence and how it exits and ceases the exit. Okay, now if we talk about data dictionary. Now, data dictionary, the name itself says that we have information about the data. Okay, now what would be the information that is stored in this dictionary about the data? So it would define, it would represent, or it has a collection of names. Okay, names of the data, its definition means its introduction, its and the attributes, the information about the data elements are being used or captured in a database information system or a part of a research project. Okay, so in a data dictionary, we usually have the names, the definitions, and the information related to them, and they are being maintained in that particular dictionary. Now, data dictionary would describe the meaning, the purpose of the data elements. Purposes of data elements within the context of project and would provide guidance on interpretation, accepted meaning and representation. A data dictionary also provides metadata about data elements. The meta include in a data and dictionary can assist in defining the scope and characteristics of data elements, as well as the rules for their usage and applications. What is a data dictionary? Why do we need it? What is exactly the use? Okay, what exactly data dictionary is? We have studied about its definition. Now, what's in a data dictionary? What is there inside it and how it can help us? So it usually stores and communicate metadata. So we know that information about a data, okay, that is index of an data, that is called in metadata. Okay, a data which have an information about another data, that is usually called as in database data, sorry, metadata. So in data dictionaries, it stores and communicate metadata about data in a database, a system, or data used by applications. Now, data dictionary contents can vary, but typically include some of the followings. Okay, now data dictionary has different data. Okay, metadata it would have, and it would have their applications used by application, different applications, but it have few more things. Now, a listing of data objects. That means listing of data objects means about their names and definitions. Now, next it has a detailed properties of data elements, data type, size and nullability if something is missing, if it does not have any information about it. Now optionality, where things are required, where it is not required, and their indexes. So these would be the detailed properties of the data elements. Now entity relationship and other system level diagrams. Now the ER diagrams are also there, which depicts the relation between various entities and how they are being working on. So that is also being shown in data dictionary. Now the next is reference data. Reference data means classification and descriptive domains. Now missing data and quality indicator codes, business rules such as for validation of a schema or data quality. So these all things are present inside data dictionary. These all information, these all things help us to assess or to use that information which is being provided in the data dictionary. Now we have seen what is the definition of data dictionary, what's there inside data dictionary, but why do we use it, why use a data dictionary? So let's see the usage where it can be used, where it can be helpful. So we use data dictionary. Data dictionaries are usually useful for number of reasons. In short, they assist in avoiding data inconsistencies across a project. Okay, data dictionary would help us to avoid data inconsistency, and at the same time, it would help us conventions that are you to be used across a project, and it would provide consistency in the collection and use of data across multiple members of a research team, and they would make us work easier to analyze and understand, and it would help us to enforce the use of data standards. Thus, it would help us to make the use of data dictionary. Okay, this is the use of data dictionary. Okay, so we was seeing that how we can use data dictionary at different places, so it can be useful for number of reasons. It would help us in avoiding the inconsistencies. If we are working on a project and we are dealing with inconsistencies, so it would help us to remove those inconsistencies from the working project. Okay, that are not the data which are not supportable for that particular project. It would help us to avoid or to not to use such things. Now, it would always also help us in defining conventions that are used for projects. That means whatever things are required, which can be useful, which can play an important role in completing that project successfully. So it would help us to know about the data which is useful. That means our data dictionary can be used to avoid means not the data which is not useful or necessary for the project, and at the same time it would help us to identify which is an important data for us, which can be used in different modules or in different areas. Now, it provides consistency in the collection and use of data across multiple members of research team. Now, it would make the consistency of the collection, and at the same time, it can be distributed or it can be used by multiple number of people. As we know that multiple teams work on a project to complete it, so it would help us from that data dictionary would could we can identify the data which is useful for us, and we can distribute that data among the team members who are working on that particular project. Now, it makes our data easier to analyze. Now, the best part about data dictionary is that it makes things very easy. It makes things very easy to understand and easy to implement and easy to modify and use. So, easier to analyze, easier to go through, easier to access. Okay. Now, enforce the use of data standards. So, these were the few uses of data dictionary. Now, if we talk about what are data standards and why should I use them, as the last point about the use of data dictionary was enforce the use of data standards. Now, data standards are the rules how we should use the data available in the data dictionary. Okay, so data standards are rules that govern the way data are collected, recorded, and represented. So it tells us how data is being collected from different resources. What were the resources? What is the authenticity of the data? So it would always define us the source of data from where it has been collected. Now, it would tell how the data is being recorded, okay, in which form it has been recorded, what is the structure, what is the layout, what was the aim of recording that data in that particular manner, and with the record we have the representation, how the data would be represented. Okay, now standards provide a commonly understood reference of the interpretation and use of data sets. Now, by using standards, researchers in the same discipline will know that the way their data are being collected and described will be the same across different projects. Now, using data standards as part of well-crafted data dictionary can help increase the usability of your research data. Now, see what exactly they mean about the data standards means it is the rules by which we can access the data from the data dictionary, and it will help us in um, understanding how the data was collected, recorded, and represented. And whenever you need it for your research work or for any project or for any model, so how you can use that collected data in different way and how you can work on them. Okay, so that is the meaning why we should use data standards. Now, how data dictionaries are used. Now, data dictionary we have understood. Now, how it would be helpful, how we can use them in different ways. Now, if the first thing we'll be talking about the documentation. So it would provide the data structure details for users, developers, and other stakeholders. Okay, so documentation. We know that documentation gives the brief of the workflow which has been carried out in that project, and it explains about the different phases and different models, different steps, different decisions, whatever were taken uh, time to time that has been declared or noted down in that documentation. So it would provide the structure detailed of the users. Okay, so who all would be using it? What is the work done by the developers? What is the interface or the software or the module or the base they have used? What was the infrastructure? What were the resources provided to them? And in what language they have worked on, how the modules were changed, what all testing was performed. These all things would be given there, and other stakeholders. It would be giving us the detailed information about the investors. Okay, when and how money was released, and which phases, and how the development was completed successfully. That all things would be covered in documentation part. Now, if we'll talk about communication, okay, so communication equip users with a common vocabulary and definitions for shared data, data standard, data flow, and exchange, and help developers gauge impacts of schema changes. Now, communication would give us how the things are being communicating, how these things are being performed. Okay, so it would equip users with common vocabulary. So you can see instead of there would be specific terms which would define the working manner or working flow of that particular project. So those vocabularies would be there while we would be having communication, which would show the progress of the project. Now, and definition for shared data, okay, which can be shared and which cannot be shared, um, what should be restricted data, that all things would be defined. Now, data standards, that means the rules would be defined. Data flow means how the data transaction is taking place among the various modules and exchange, and help developers gauge impacts of schema changes. Thus, the communication would help us to work on it successfully. Now, application design. This would help. Uh, Now, application design help application developers create forms and reports with proper data types and controls, and this would ensure that navigation is consistent with data relationship. Systems analysis enables analysts to understand overall system design and data flow. Now, system analysts, we know that those who would be working on the system and would control the whole system design, and those who would be looking after its functioning, they are called system analysts, and they would help us to find where data interact with various process and components. So these the main work of these analysts are to see how these components are working, how they are having communication with each other. how the data flow is taking place, that all things would be defined in system analysis. Now, data integration. Now, in this integration, they would clearly define about the data elements that provide us the contextual understanding needed, and they would also tell how to map one data system to another, because see, the system we are designing anyhow would be communicating. It would be taking data from somewhere, would be processing it, and would be filtering it, would be working on it. So many things would be going on. So this would help us to map one data system to another, or whether to subset, merge, stack, or transform data for a specific use. Now, decision making. Assist in planning data collection, project development, and other collaborative efforts. These would be done. Now, data dictionaries are for sharing. Okay, usually why is these data dictionary being designed? So that we can store the information of data, their standards, their definition, their abstractions, and all, and thus we can share with others, maybe a number of people, maybe a group, or maybe a team. So how does it work? We can see few examples of it. Okay. So data dictionaries are for sharing, where we can take data, we can work on it. For example, when we are working on major projects and minor projects, so usually we take data set from other organization, we work on it, we train it, and we try to see whether a model is working properly or not. Okay, so thus data dictionaries are being defined or designed. So for a group of people working with similar data, having shared data dictionaries, so those working who are those people or maybe organization, those who are working on same module can share these data dictionaries so that they can share information about particular object or a topic. Okay, and at the same time they have a proper idea of maintaining that particular data, that is the data structures, and they also provide the precise vocabularies, because see, what happens is that in every organization we would be using different vocabularies for defining the work progress. Okay, so these vocabularies would help other people to understand about your project, and at the same time they would come to know how you people are working and in which direction your work is being proceeded. So that would be also shared with different organization or the group of people. Now, in the data dictionary, what else we provide? We also provide the information needed by those who build systems and applications that support the data. Now, lastly, if there is a common vetted and document data resource, it is not necessary to produce separate documentation for each implementation. Now, example of shared USGS data dictionaries means United States Geological Survey data dictionary. Now here they have shared their data dictionary with the people. Okay, so there is a few examples. You can go in the Google and search for these examples. The links have been given. So when you click on those links, certain information regarding their position, the Earth Explorer USG Landsat satellite about data dictionary has been given. They have given about an open file of the open survey, that is 3-001 data dictionary. They have also shared the aerial photo of single frame data dictionary, the national elevation data set data dictionary, and national hydrography data set data dictionary. So these all are available. You can click on these links and you can see how they have shared their data with other people which they are working on, and how that can be used by other people to understand those situations or conditions, or they can use those data to build their own projects also. Now, it is very important to keep our data up to date. Okay, if you have created any data dictionary, and if you are maintaining some vocabularies and rules and all, so it says that it is very necessary, it is very compulsory that it should be kept updated, so that whoever goes through your data dictionary, or whoever wants to access it, can easily go through the information available there and can access the data required from there. Okay. Now, the data dictionaries can reveal poor design decisions. Now, if the work has not been taken seriously, if the things are not stored correctly, so this would result in the failure of the data dictionary. That means the dictionary which you have defined or designed is of no use. Okay, so that would be very difficult. That would be uh, now making a data dictionary. How usually we make a data dictionary? So most database management systems have built-in active data dictionaries and can generate documentations as needed. For example, SQL Server, Oracle, and MySQL. The same is true when designing data system using case tools, that is computer-aided software engineering. These tools are also there. And open sources and layers for MS Access can be used to document access databases and access connected data, that is SQL Server, Oracle, and others. So this was all about data dictionaries. So this is all about today's class. If you have any doubt, you can ask. And on Wednesday, we have a mini test. So it would be objective type. Okay. And I have already uploaded the material in the uh, Teams. So go through the material. If you feel like asking me anything, if you have any doubt, you are free to ask me anytime.
Mom, maybe leave the class.
Yes, I have downloaded the attendance, so you can leave the class. Thank you for being in the class.
Thank you, mom.
Welcome.
Thank you, ma'am.
Thank you.